Alright, so this video is for anybody with a Model 3 or Y, or potentially even a Model X or S with a hardware 3. Um, Basically what's going on is a lot of these computers, the thermal putty is failing, or thermal interface material is failing inside the computer between the autopilot processors and the water block. So the sort of symptoms you're going to see in that situation is you're going to be driving along and you're going to get an autopilot disconnect warning telling you to take control, or your cruise control is not going to work. You're not going to see any of the visualization of cars around you or anything like that. And then you're also going to get some alerts. Of course, my car is already fixed, so you're not going to see, or I can't show you exactly the alerts or symptoms. But if you're getting those sort of messages and you suspect that maybe the computer is overheating, what you can do is go into service mode. And if you haven't been in service mode, you go software, and then you go to your vehicle, hold down on the Model 3 or Y or whatever you got name, and then you hold it down until it gives you the little indication, and then let go, and then it'll pop up with a screen, and then you type service, hit OK, and then it'll bring up this warning, enter, and it'll bring up service mode. And then what you're going to want to do is go to vehicle info, and then alerts and DTCs. And so as you can see on mine, there's no active alerts, but I've been doing a lot of work to my car, so there's a lot of different alerts going on. But we'll go back to when I was having the issue. Which is somewhere around July. There we go. So July 8th. So we got APS underscore W130 ECU thermal issue. So basically what it is the computer has reached 80 degrees. I believe it can sometimes reach higher, but 80 degrees is generally the cutoff, and the computer will shut itself down. The autopilot computer will shut itself down to protect itself. Now, so you'll get this code. You might get some others. You can see it came in here. There's another one, ECU thermal issue, APP underscore W141 ECU. Let's see. Basically, autopilot electronic control unit, ECU, board temperature is outside recommended or operating range. And on this one, it reached 96 degrees. So anyways, basically, it's just overheating. So you get a couple alerts like that. You'll get a couple issues like that, and then they'll clear themselves. Like once the computer cools down, they'll clear themselves. So you'll want to look in recent events, and then just look for codes like that. And then another way you can also troubleshoot it is you can go into the little snowflake for your thermal system, and you can go coolant system, and it will give you temperatures. So you got your autopilot computer, and then you got your infotainment computer. So I'll show you later, but the hardware 3 computers are separated into 2 boards. You have your infotainment board, and then you have your autopilot board, and they basically sandwich a water cooling block. And then you have this basically represents the water going through, or coolant going through it. And you can see mine's running a little hot. I'll explain why that is that way a little bit later. But basically, if you see this trending up, like in 75, 80 while you're driving, that's a pretty good indication that the thermal interface material is starting to fail. you know, you want to check other things as well, like make sure your temperature here isn't like crazy high. Make sure your radiator health is good. That can cause overall issues. So like, let's say your AC isn't performing as well or something like that. You want to check the basics. So like radiator, make sure it's not full of debris. You want to make sure that your cooling system is topped off and it doesn't have any air bubbles in it. Now the way the hardware 3 computer is mounted, it has a very bad tendency to catch air basically, and then you have a large air bubble in it, and that can cause thermal issues. So you want to make sure it's properly purged. But if it's purged, water is good. I'm sorry, coolant. The coolant level's good, radiator's good. You know, you don't have any other thermal management issues, then you will want to proceed with this video as far as repairing the hardware 3 computers. A couple other things to note. You got your coolant purge start, so if you're going to want to try and like purge the coolant, that's one of the routines you're going to want to run. You just kind of want to look at everything, like, you know, battery temperature, so infotainment temperature. Now, if let's say you see your infotainment temperature like really crazy high, then that's another indication that you have a bubble, you have a water bubble in the water pocket in the computer water block. Yeah, that's the main thing. So yeah, just remembered for your thermal system is you're going to want to go into so you have thermal actions, and then you're going to want to go down to here to self-test, and you're going to want to run the test thermal performance. That's going to make sure that the rest of the system is working adequately. Sadly, when it fails, it doesn't tell you like, hey, this is wrong. It just says a fail. So you'll have to do some more troubleshooting to really figure that out. But the big thing is the autopilot temperature being excessively high. Another thing you can do, so this is more about service mode as well. So when you go into service mode, it's going to tell you, as you can see here, speed limited. So you're going to want to go to here, service settings, and you're going to want to remove speed limit. That's a big thing. And then if you want to listen to music, enable phone Bluetooth, unless you got Spotify or whatever you want to use. And you're going to want to drive it, and you're basically going to want to, you know, do it safely, of course. Drive the car. Watch your temperatures, because it's gonna get warmer as you drive, because it's actually gonna have to interpret the things around the car and actually process that information, and it's gonna generally consume more energy and therefore make more heat. So that's just another thing to check out when you're troubleshooting this. And then when you're done with all this, to exit service mode, you just hold down the little exit door. And there you go, you're out of service mode. Yeah, and then we'll get into the actual repairing of the computer. I would like to do a video on removing the computer, but I'm kind of limited on time and resources. I'm living in an apartment at the moment. But there are some good videos on removing the autopilot computer. The big thing is you're going to have to open the cooling system loop, so detaching the water lines going to it at the firewall, or coolant lines. You do not have to fully drain the system. You can just simply disconnect it, have something to catch the fluid or coolant that comes out. It's not going to really be much. It's pretty high in the system, and then you can just pull the lines up as high as possible, and you'll lose minimal fluid. And then from there you can I would suggest Plugs, Harbor Freight sells a good set of plugs. Just the little silicone rubber plugs, and you can just cap off the line so you don't get any coolant drizzling into the cabin when you pull the computer out. It's basically just pull glove box, pull this upper trim, and there's a couple other things, but you're also going to have to power down the car, obviously. There's videos on that as well, but basically you're going to pull your battery in your frunk under the bezel that's just below the windshield. You're going to be pulling that. You're going to be disconnecting your battery, either 12 volt lead acid or lithium, and then you're going to go under the back seat and disconnect the battery to fully de-energize the car. And there's some other things you're going to want to do, like, you know, make sure all your doors are open before you shut power off, because of course they're not going to open, or at least your back doors. Front doors, you'll still be able to do the manual release. Those are a couple little tips, but I would definitely advise checking out some videos on it. Another thing too is you're going to be removing an airbag, so you're going to want to practice good safety on automotive airbag removal. It's not a big deal since the car's already powered down, but you're going to want to wait. You know, I would give it 30 minutes to just be safe. Let the capacitors discharge in the airbag computer, and then when you disconnect the airbag squib, it's going to be it's pretty straightforward. You just pull it out. There's like a tab you pull back, pull it out, disconnect it. It's safe. They are designed to ground the pins automatically when you pull the connector, or short the pins, so stray voltage can't deploy the bag. But just, you know, play it safe. There are inverted Torx, and it's mainly Torx, inverted Torx, and Phillips, number 2 Phillips, to remove the airbag, glove box, and all those parts. So I definitely get a good set of those. Harbor Freight sells them. All right tools for that. And yeah, and just as a warning, if you destroy the autopilot computer, you destroy it. Or there's a couple ways to look at this. So if you take it apart and you ruin it, you're going to have to go to Tesla and have them replace it. As far as I'm aware, Tesla will only install a new computer. You can't get a used one or a good used one and take it to Tesla and have them install it. Now, I don't know, they're in your area, there might be a third-party place that would be willing to install a used computer. I'm not sure if it's even possible in the Tesla's service toolbox. To do that, you need special authentication to replace an MCU, just because it is tied to your anti-theft module, which is down in the console, and it is tied to your VIN. So it's a big process for them. So anyways, the gist of it is they're going to want to install a new computer if you break it. But on that same note, it's already bad. Their fix for this thermal issue is to just replace the computer. Now you could maybe hold out until maybe they decide to make a hardware 4 retrofit for the Model 3 and Y, to replace the hardware 3.3 computers. But of course, you know, who knows? They've already said they're not going to. But with Tesla, you know, they say things and then they do other things. So that's kind of my perspective on it. My philosophy is go fast and break things. If somebody says you're not qualified to do it, well, screw them. Do it anyway. Try it anyways. The only way you can really learn is to screw up. But just understand how that will affect you. You know, if this is your only car, if it's, you know, somebody else's car, you know, just understand, you know, how what you do can affect other things. But nonetheless, it's better to fix something than just throw it away. Tesla, they will actually decommission the computer. Most of the places will decommission the computer. You won't be able to get it back from them without it being completely destroyed. Like, they actually have specific instructions on how they're supposed to drill holes in all the major chips and flash memory devices. And it's just, I don't know. It's just a big waste. So it's, it's probably better to at least try and fix it. But yeah, let's go inside and look at some computers. All right, so we're at the workbench. A couple tools you're going to need. You're going to need a T9 Torx for pulling everything apart, and then I think it's going to be, so if you have an older Intel-based hardware 3 computer, you're going to need a larger Torx. I think this is like a T20 for the surrounding bolts for your manifold, but you'll need that. Everything in here it's all Torx, pretty much all T20 once you get into it. Also, if you have a Ryzen based, I believe it is also T20 for the mounting bolts for the manifold as well. So these computers have already kind of been prepped. I've already taken them apart. I've cleaned most of the thermal paste or thermal interface material out of them, and basically just going to show you a basic teardown and what you're looking for. So I was talking about the air pocket issue. Actually, we'll talk about the air pocket issue later once I get them apart, and you'll be able to kind of see what's going on there. As far as other tools, you're going to want to, for best results, you don't need it, but it's best to have is an anti-static mat that's grounded, as well as a anti-static wrist strap to prevent any potential static discharge into the circuit boards, causing either current failures or latent failures. But I mean, you could do it on like a tile table. You just don't want to use like directly on like the cheap particle board or anything like that. Those kind of tend to, it's coated with vinyl, so they kind of make a lot of static. Couple tool, also back to tools. If you don't have like smaller Torx, if you go to Micro Center, if you're lucky to have one of those nearby, you can get this little inland little screwdriver set that basically comes with all the Torx you're going to need to take these apart. You can also do the iFixit basic bit set. I think these are like 15-20 bucks. You can do it that way, or I mean, you can get everything from as far as tools, you can get everything at Harbor Freight. The big thing is the T9 and the T20 for taking the computer apart, and of course you're going to need some other Torx for taking the car itself apart, along with inverted Torx and stuff like that, like I mentioned earlier. So hardware 3, there's 2 main versions that I'm aware of. You have your Intel based, which uses the Intel Atom processor for the infotainment, and then you have the Ryzen based, which uses the AMD Ryzen CPU for the infotainment. Now, as far as I'm aware, the chips for the autopilot computer are the same, but there's also some differences in the boards as far as I/O connectors and stuff like that. Nothing you really need to be worried about, but the big thing is Intel, AMD, a couple little differences. How they come out of the car is basically identical, except for maybe a couple additional connectors. But they both mount at the back. So this would be the firewall would be here. You have your 4 mounting bolts that hold it in, and same on both Intel, AMD. For removing these, I call them manifolds. I'm sure Tesla has some other name for them. This is the first thing you're going to want to do. Is they have these is pull these out. They're both the same. They have these quick disconnects. Small clip. These are already kind of mostly detached, but the big thing is you have these quick disconnects. That's the first thing you're going to want to get off. Basically, you're going to want to pry these tabs out. You don't want to go too far, else you'll break them. And you got to pry them both out at the same time to get them over this ridge here. Once you get them pried out, so I recommend like 2 small screwdrivers, preferably if you have 2 people, 1 person to hold it down, hold the computer down, or if you have a vise or something like that. Hold the computer down, pull these tabs at the same time, and then pull your coolant connector off. And then, of course, expect coolant and stuff like that. These have been well drained, so shouldn't have any issues with spillage. So you get both those off. The Atom is the same way. The Intel Atom is basically the same exact connector. It's just this bracket's a little different. So you get those off. And then on the Atom, it has through bolts that go through the whole computer. So you got, I don't remember which direction, but you're going to have this. It's basically just a T20 on one side, and then I think probably an 8 mil nut on the other side. Take it off. Pull out your bolt. And then you'll do that for, there should be 4 locations. And then also you're going to have a ground strap. That's going to be on one of those. Make sure to remember where you put where the ground strap came off. All right. Battery died there, so we're back though. So you get your bolts off, and then this will just lift off. With the Ryzen or AMD, you will have these T20s. You will have 4 of them as well. You just take them off. Take off your quick disconnects, and then this will come off as well. So pretty similar, but yeah. So let's start with the Intel based one. Get this moved to the side. So looking at it, you'll notice the big thing is there are 2 PCBs, 2 sets of connectors. These are all your camera connectors. And then, so this is your autopilot board. And then this board is your infotainment. You can see this is your display. Oh, I'm sorry. That is not your display. That is, I believe, an Ethernet network connector. So on Intel, display connectors here. And on the Ryzen, it's kind of like over here. You'll see later, but not a big deal for what we're doing. But first thing is, pop your covers off. It's going to be just a bunch of T9s. Just all around here. So on Intel, it's like 4 for the infotainment side. And then that just lifts off like so. And then your network card, it will have 5 screws. Make sure to remember, sort your screws. Do little cups, do maybe a piece of paper, and just label where the screws came from. You want to make sure you put them in the right locations. I don't know if you're going to do anything catastrophic damage, but if let's say it's too short and it can't hold a part in place correctly, you got problems. So just record where your screws go. So your modem, If this is European, it's gonna look different. I believe those ones are a little bit longer and they kind of come out of the case. But the gist of it is you pull it down and it comes off. Set that to the side, and then you're going to have basically screws along the outside. I do not have all of them in, just because I already had this computer part, and I mainly just put it back together for demonstration purposes. But we're going to go ahead and just all right. So we got the screws out. So mainly it's just these ones along the edges, and then for these X brackets that actually hold, like, so this one's your little computer card, and then this one's actually for your audio amps. But so you get those off, and then it's gonna be pretty stuck. This one's super easy because I already took it apart and cleaned most of the thermal paste out. But basically, you're gonna want to lift off the corner. You're gonna want to make sure you lift on the board, and not on the connectors. You could potentially break them. So you're going to lift, you're going to apply pressure. It's not going to release immediately. They're usually pretty stuck. So just a little pressure, and you want to just keep constant pressure, and eventually you'll just kind of let go. So you'll just pull, maybe try a different area, maybe get a little leverage, but eventually it will just release, and then you can. There's also these little studs here you want to pull it off of. And then there you go. So this is the Intel-based Hardware 3 infotainment board. You got your little Intel Atom there and its RAM. You can see it's kind of like on its own, like little daughter board that's soldered in. These are your audio amps. These have thermal paste as well. These have thermal paste. You can basically see where anything that protrudes has will get thermal compound or thermal putty. Now, you can just skip this step and just do the autopilot side. But my viewpoint is this is all put together at the same time, relatively the same amount of thermal cycles on it. Now, of course, especially if it's Intel, the Intel version, these don't run nearly as hot or produce as much heat. So, you can get away with just skipping this part, just flipping the computer over, and just doing the autopilot side. But I recommend, for best results, just do both. And you only got to go in there once. Because who knows, maybe in a couple of years the thermal paste will start to show signs of degradation, and your infotainment computer will start overheating. So basically that's that. Put that to the side, and then this is the water block. We'll talk about the water block after we get the autopilot computer out. So you'll flip it over, and then okay, again, this is just demonstration purposes. I already removed most of the screws. These little inland screwdrivers are a little they're not the most powerful. It's probably meant for really like smaller stuff, like phones and game consoles and stuff like that. So you get this cover off, set it to the side. This is the back side of your autopilot computer. You'll notice some capacitors have been broken off. This one's been pretty beat up. But you'll get all the screws out, main ones, same thing with just like the infotainment computer, just along the edge. There's a couple. And there's another one, and then you have X brackets, and I'll just pull those out and bring it back. Alright, so got all the screws out. One's on the perimeter, and then your X bracket screws. Now, so if you pull the infotainment board out and you kind of notice how much pressure it takes to take out, The autopilot side is going to take probably 3 times more pressure, just because there's a lot more surface area with thermal compound. So same sort of thing, you're going to want to start at the side, and you're going to just put some pressure on it. Of course, this is, thermal paste has been removed, or thermal compound has already been removed. So kind of pull on the side, and these are pretty, like, so, like, these boards are like automotive grade, so they're a lot more robust than like what you'd find in like a video card or something like that. They're thicker, they have heavier traces. They're just, the build material is a lot sturdier. So you can kind of, you know, you can mess with these a little bit more, but you still want to be careful. So side again, pull up. It's not going to release immediately. You're going to want to just keep constant pressure, and eventually, you know, you're going to kind of work it. You know, sometimes if you can kind of move it around, that helps as well, because it's just a little bit of play in the board. So if you can kind of work it back and forth and pull on it at the same time, you can usually work it loose. Now, so this is 2 separate processors. So you're going to break one loose, and then the other one's going to probably still going to be stuck. So you're going to want to go to your other corner and break that one loose. Basically the same, you know, wiggle, pull up. Now, once you get them loose, you can go ahead and just lift it out carefully, of course, with 2 hands, and there you go. Now, just gently set it down here. So this one's a little bit more complicated compared to the Intel infotainment computer. So you can see we got our autopilot computers. I'm sorry about the lighting, you can't really read. There you go, you can kind of read it. Autopilot computers, it's 2 independent systems. They have separate power. They have separate power coming in. They run independently. They have separate power management, everything. But you're going to see a lot more thermal paste just kind of around. And basically what this is most of these are just, sorry, most of this is just power management, and it's basically cooling MOSFETs. So you're going to want to pay attention. You're going to want to take a picture, basically. You know, you're going to pull it out. You're going to see all this. You know, some of it I've already removed, but you're going to see all this, and you're going to want to take a picture so you know where to put the new thermal putty. So, and on the heatsink side, you're going to see where the processors contact along with the RAM at the sides, and then you're going to see a couple little standouts and machine surfaces where it's meant for thermal compound to be applied. So you're going to want to make sure you clean a majority of the material off. There's 2 ways you can do this. You can just clean the surfaces off, you know, scrape off. Now I recommend plastic scrapers, and you can scrape off the dried out thermal compound. It's gonna just flake off. It's not really gonna be sticky or anything like that. It's just gonna flake off. You want a plastic scraper. Sometimes people call them spudgers, but you know, they're very common with like dismantling like phones and stuff like that. They're soft pry tools, and you use stuff like that to just clean the surfaces. So you're gonna want to clean the top of all your MOSFETs, your memory, the chips, the processors, I mean, and go from there. Now you don't need it perfectly clean. This is non-conductive. The thermal compound is non-conductive, so you can get it everywhere and you're going to be just fine. As long as, of course, you buy now the stuff on it from the factory, that's non-conductive, so that's fine. But of course, when you buy new thermal paste, thermal putty, thermal interface material, whatever you want to call it, you're going to want to first get a non-conductive material. So when you put this together, you know, if it smushes out, it's not going to short anything out. But So that's just like, so here, I'll show you on this RAM here, or memory. So you can just basically, so this is like the spreader tool applicator that comes with the Thermal Grizzly thermal compound. It's plastic. It's pretty good for scraping this stuff off. But you're basically just gonna get under it and just push it off. And the main thing is you want the surface of the chips to be clean, because that's where they generate, where most of the heat kind of propagates, and that's where you want to sink it to the heat sink or thermal water block. You don't necessarily need to worry about the stuff between. If you want to get OCD, you can. You just want to be careful because there are a lot of very, very small resistors and capacitors all around the board, and you do not want to knock any of those off, or else you're going to have lots of other problems. You can see on this side of the board here, so this is, some people will call this, like if you're familiar with video cards or computer motherboards, you'll know about like power phases, and it's basically just kind of like a set of devices used to convert, in this case probably 12 volt down to probably like 1.2 volts for the core and memory. Anyways, I don't want to get too in the weeds on this, but this is basically your MOSFET, or power management device. That's what makes the majority of the heat. So you're going to want to make sure the top of that's clean. You will see sometimes on these inductors, the big square gray guys, they will also have thermal paste on them, and you're going to want to scrape that off as well for new thermal compound. You got to see how the factory application is very, it's done by a machine, but they, it's better too much than too little, because it's non-conductive. I mean, you could literally coat the whole board if you wanted to get crazy. Of course, that's probably not, a good idea, but non-conductive, not a big deal. And then you go over here, this is more power management devices, so you can even use your fingernail. You're basically going to want to just peel all that off. You use like toothpicks or anything else to just kind of get in there and pick it out of the little crevices and all that, but it's not 100% necessary. If you want to get crazy, you can, but the main goal is to clean the surface of the chips and inductors, and apply fresh thermal interface material or thermal putty to allow this to cool again, or to properly transfer heat from the chips into the water block. Now, I don't know if this issue, as far as overheating, I don't know if you're going to encounter too many Intel-based hardware 3 systems having this issue, mainly because of how the water block's designed. You'll notice these are copper, so these are copper's very good at heat dissipation, and basically they've attached that to the water block. So I imagine with hardware 3 Intel, the Intel version, you're not going to encounter this as bad. But to show you an example of what you'll see when you pull these apart, so dark brown, so the thermal paste is basically like a light pink, the factory stuff, and you will notice that this came off one of the processors, and you see how it's all dark. If you bend it, it breaks. It's it's very thermal cycled, overheated. It's nasty. See, it just crumbles. And you will notice, so this came off like some MOSFETs or something like that, and you'll see it's a brighter pink. It's flexible. It's still dried out, like it's still gonna break and stuff like that, but it's still, I mean, this is just kind of to give you an example of what kind of like thermal issues these computers have with this thermal compound. I mean, some people might say it's cheap thermal material. It's probably just, they engineered it one way and they thought it would work and it didn't. And Tesla kind of didn't want to fix it under warranty or recall. But so this is basically the gist of the Intel version, the differences and all that, and then we'll turn over to the Ryzen version of the MCU for everything else, because I believe that's going to be the main one that you're going to be tearing into. So, another thing on, so the water or coolant bubble issue. So it sits in the car basically like this. It's upside, I mean, and then with your little manifold, this is just kind of a demo, but just to kind of talk about the issue with the air pocket and whatnot. So this is bolted to your dash. You got water coming in. It's near the top of the system, and basically it's just, you can see how it kind of forms a U. So water comes in through, you know, your ports. It goes down, then goes through the block, and then it comes back out, and then back through the other port. Now you can see, like this is a perfect trap for air. Like, it's very possible for air to get just trapped in here, and it's hard to get out. So when it comes to refilling the system, you're going to want to use a vacuum fill system or tool. The one from Harbor Freight, the cheaper one, works pretty good. It doesn't really fit the coolant reservoir that well, but it will work. You just kind of have to hold it on there, and you're basically going to want to vacuum fill it. You look on YouTube and you'll see some videos on vacuum filling these kind of cars, but you want to ensure or try and guarantee that you are going to have as little air in this upper pocket here as possible, because basically when water comes in, it's going to kind of go over here. If there's a bunch of air, it's going to kind of spill over and just wash down and go out, and then you'll have a huge pocket of just no water contact. And the way these conduct heat away, you can see that basically one of your autopilot computer processors is just going to be pretty much just dry, and it's not going to conduct heat away from it adequately, and you're going to have overheating issues. That's why you want to really make sure that you do not have bubbles in your system before you start to tear into this, because you don't want to do a false diagnosis and it turns out it was just air in the system the whole time, especially with all this work. So anyways, get these out of the way. Let's see. Oh, uh-oh. Another capacitor broke off. Yeah, you don't want this to happen. These computers are basically junk. I just got them secondhand for this video. We'll gently put them to the side onto the case. See, this stuff. Another thing too is like this thermal interface material just kind of gets everywhere as it breaks apart. So this is the main one that you're going to find having issues. So this is your Ryzen based hardware 3. Some people call it like 3.2, 3.5. But you're going to notice your video port for your main display is on the side. And then if it's a Model X or S, you're going to have another connector here for your rear display. As you can see, there's a second display. But on the, of course, on the 3 and Y, they do not have that second display connector. But so starting from the same direction, on the Ryzen version, I would strongly recommend the replacement of thermal paste for the infotainment board more, because the Ryzen makes a lot more heat than the Intel Atom. But anyways, so we're gonna just pretty much same disassembly, you know, screws on the perimeter. I believe they're actually larger, slightly larger screws. Once again, you know, label your screws, pull your cover off. A little bit different layout. Modem, basically the same. It's gonna have 5 screws. Now when I say modem, I'm talking like cell. Like this is basically your cell phone modem for your connectivity. So 5 screws, pull down, comes out, that to the side, and then you're gonna have screws around the perimeter. I just put in like 2. Anyways, you get all your screws out, especially this little, it only has 1 X clamp on the Ryzen version. So you're going to take that out. Now, back to the whole, you know, light pressure, keep it constant. Eventually, it will break free. Oh, missed a screw. That's another thing is, you know, be gentle. You don't want to force anything. You may have forgotten a screw or something like that. Also, if this is a Model S or X, you're going to have another connector up here. This is for the discrete GPU that's buried in the computer. It's basically going to be 2 screws and a connector you're going to pop off, and it's going to have a cable that just goes to the side. But of course on the 3Y, it will not have that. So, gentle pressure, constant, it'll eventually come up. And then this is your Ryzen infotainment computer. It's a little bit different. You can see here we got our nice little Ryzen CPU there, or sorry, APU. It has built-in graphics. It's RAM, a couple other things. That's a NVMe storage there, power management, and then it's going to have a lot more stuff for the audio. So audio amps are in a little different area, and then it has a couple more chips for that, and of course some big chunky inductors. So once again, take a picture as soon as you get it apart before you clean anything off, and then proceed to, you know, scrape and gently remove all the old thermal paste. Now I noticed on the Ryzen base they have like a primer. You see this gray stuff? I'm not sure if that's going to be, if that can cause an issue, but I recommend taking it off. So preferably a static safe bristle brush, you know, something basic, and then you can literally, as long as it's soft enough, you can just do a little light scrubbing, and it comes right off. Now, I don't recommend using solvent because it just kind of dissolves the thermal compound or thermal interface material, thermal putty, and it just kind of makes a big mess. It's easier to just scrape everything off, you know, do a little brushing, and then if you have compressed air or one of those little, a can of like dust off or something like that, and just blow it off. It doesn't really stick to anything because it's just so dried out. Generally, it doesn't stick to anything. And then you just want to make sure it's clean. You want to make sure you're handling it right, all that good stuff. So, oh, and especially on the Ryzen APU, if you see here, you got all these little passives all around the CPU core. You really do not want to break any of those off, so you want to be very gentle when you clean around that. But the big thing is get the core clean, or the face of the chip clean. Now, another thing on thermal compound, if you notice on the instructions on a lot of these, they say not for direct die cooling. And of course, as you can see here, we have a die covered in thermal putty. So that's just Tesla doing Tesla things. Of course, these don't really have an issue of overheating that I know of. So, you know, if you see that when you're looking up, we'll talk about it later, but when you're looking up a thermal compound to use, or putty to use for redoing this, and you're reading through the instructions and all that, and you see a warning not for direct die cooling, Tesla figured out that it's okay. Eventually I'm going to do some experimentation on like actually using like a thermal paste or maybe thermal pads or something like that, which I have a test bench for these, so I can run them outside of a car and maybe get some like thermal performance numbers. But anyways, not a big deal. You just want to use a good quality thermal putty. But, you know, take a picture of the board, clean it, good to go. You also see on the inside here, so you'll see a lot, compared to the Intel one, you will see a lot more little platforms for thermal paste. So of course, take a picture, and then after you get your picture done, you're going to, you know, just clean all of this off. Just go through the whole thing. It doesn't have to be pretty, but you want a majority of it off, and you want the surfaces to be clean. Now, another thing, you will notice this plate here has a cavity below it. Now, on the S and X, this is where your discrete video card is. So there's 4 screws here, here, and here, and here. Sorry. You'll take out. And then I recommend, you know, even if it doesn't have the video card, take this plate off, because there is thermal interface material between it and the heatsink. And it's probably best just to change that. So you're gonna basically just pop it off. It's gonna be pretty stuck, but you'll pry it off, come off, and you can see where it touches. There is thermal putty on each one of those contact points, so you'll want to remember to put more thermal putty there. And then if yours is an S or X, you'll have your video card here. Sorry, I don't have one to show you, but it's basically going to be the same deal. It's going to have an X clamp. It's going to have some other screws. You're going to take those off, and you're going to gently pry it out. Careful with the ribbon cable; those are very brittle, fragile. And then you'll same process, you know, clean. Yeah, you clean it. Take pictures, clean it, you know, and then we'll get to application later, but yeah. So, and then on the opposite side, you'll see thermal compound as well. All right, so that's basically all of that. So let's go to the autopilot side. You see, I already have this one. Same deal. It is just screws on the perimeter. I already had the plate unscrewed, so I just got like 1 or 2 screws in holding this. So same thing, light pressure on the side, maybe jiggle a little bit, get it free. One side will pop loose. You go to the other side, pop the other side loose, and then you will be able to lift it out. So, pretty much similar layout as the Intel based one. It's a little different. But same deal. You have your power devices, MOSFETs, inductors. Of course, this is already partially clean, but you're going to want to take a picture before you clean it, so you know where everything goes as far as the thermal compound You know, same thing with the heatsink or water block side. And then you'll basically reapply it. I will show you one chip on how to reapply it. I do not have enough to do a whole board, but it's basically it's the same. It's the same for everything on here. You know, you're gonna clean it. You know, like this side, I really like super clean this. You know, I got all the thermal compound out. All the compound out from between the chips, and I brushed it and all that. You don't need any solvent. All this stuff will just flake off, but you know, make sure you're being delicate. You're not breaking any of these small little resistors or capacitors off. So you can see this side I haven't cleaned as much. You can see how it just gets down in there. But the big thing is clean the top of your chips off. Another issue, so the thermal issue with these computers is sometimes it will just kill them. If your computer has like a thermal event, it shuts itself down, it does not come back when it cools off, you know, try and reset. There's some troubleshooting you can do. You can try and just do a full reset of the car. You can do a DAS reset, driver assist system reset. Sometimes that will bring it back. But sometimes, you know, just from the thermal cycling and the high temperatures, like these chips will either, I'm not sure exactly what goes on, if the chips fail or if possibly I've heard of issues with the solder contacts. So these are BGA, ball grid array. So under this chip, there's somewhere around like 900 contacts that are just made with these little solder balls between the chip and the board, and supposedly those can fracture and cause issues. I'll be doing more videos eventually on in-depth repair on these. I feel like once Tesla cut support and they stop making these and they don't give you a path to hardware 4, these computers are going to be, you know, you're going to be wanting to fix these and maintain these a lot more. But anyways, a couple differences. One of the reasons why I think the Ryzen version of this computer fails more is, you see on this heatsink or thermal block, sorry, water block, you see it's just it's just aluminum, like that contacts your autopilot computers. I don't know if perhaps the autopilot computer processors are possibly different in that they produce less heat. You know, it's just like a newer manufacturing process or something like that, and that's why they deemed it okay to just have straight aluminum instead of like on the Intel version where you have these copper heat spreaders that are then looks like soldered to the aluminum water block. But anyways, dumb little detail, not super pertinent if you're this far into your car, just a little dumb observation. So you got it apart, hopefully you didn't break anything. The next thing is clean it, you know, take pictures, clean it, get it ready for reassembly. Now, as far as thermal compound, there's a couple different options. You can go on electronic supply website like DigiKey, and you can find something like this. Sorry, I don't have any screen capture programs, but this stuff's pretty nice. It comes in a syringe. That's the part number there, and it gives you a whole bunch of information. It's kind of nice when you buy something like this off DigiKey because you can have a little data sheet that will tell you everything about it. But the big thing is that you want to look for is thermal conductivity and is it conductive or not. Thermal conductivity, so you can see this is operating range as well. So that's storage, refrigeration. Anyways, it's in the, there we go, usable temperature range. So this one will work. You know, I don't think your car is going to get below 60 degrees Celsius, but sometimes they, you know, they're just not meant. They're not robust enough for automotive applications like this. Anyways, this one's nice. It comes with an applicator, the gun, and it's in a tube. Very easy. So this is 100 cc's, I think. 100 grams. It's 100 grams. You're going to need at least 60 grams to do a Ryzen. If you do the entire computer, you're going to need at least 60 grams for a Ryzen-based hardware 3 computer. So this is a good option. Another option is, let's say you got a Micro Center near you or some other computer supply store. This is just an Amazon listing, but you can use, literally, it's for video cards. Generally video cards, other computer stuff. The Thermal Grizzly, it's really good. However, they do not publish exact specifications on like thermal connectivity. They have like a big spiel about it, but they don't publish it. Anyways, you want to use the Pro putty, this brown stuff. This is all thermally non-conductive. You want the Pro. It has the best connectivity, supposedly, and operating range. Now, so earlier in the video, I mentioned my computer and why it was running hot. It's because I used the basic. It was just what I had. It worked, but it still runs kind of hot, and it will probably fail. Eventually, I'll have to redo it. But you want to use the Pro. It's expensive. This is Amazon. It's $45 for 30 grams. So you're going to need two containers to do it. But you know, I don't know. I don't remember the saying, but you know, you buy it once and then you don't have to worry about it. You don't have to buy it twice. So get the more expensive Pro, or if you find something good on DigiKey. So like this is another one on DigiKey. I don't think this comes with a gun, but it is good for. So it's 8.00 watt. Anyway, I don't know how to describe that, but anyways, it's better. Bigger number means better. But of course, this is 100 grams, and it is $110. So you're going to spend at least $100 on thermal compound for this project. Eventually, I'm going to do experimentation with like pads and stuff like that, as I mentioned earlier. But for now, I'm just trying to make this video to help people out who are having issues with their autopilot computer, especially with the new version 14 autopilot or full self-driving version 14 lite. It seems to be cooking a lot of these computers that have, you know, already been failing or slowly dying because of bad thermal compound. Anyways, when in doubt, just do the Thermal Grizzly Pro. You can get on Amazon. It works. You know, enough said. If you want to do more geeking out on just, you know, different thermal compounds, you know, be my guest. But when in doubt, Thermal Grizzly Pro, Amazon, $45.99 a piece, varying on your area. And it's 2-day shipping, or 1 day. You get it tomorrow, varying on your location. So 2 of those, that'll be good. Now back to, this is what I have, a little bit I have left over from when I did mine. This is the basic, but this will work for our demonstration. It's going to come in little containers like this. You're going to get these little spatulas for applying it. And basically, after you get everything clean, you know, water block, boards. Get this out of the way so I don't damage it. You know, get everything nice and clean, ready to go. There's 2 different ways you can do this. You can apply it to the water block, or you can apply it straight to the chips. Water block's a little bit easier to know where it goes because it's basically anything that protrudes and gets thermal compound. But follow your pictures, and basically, here, let me Let me pause for a second so I can do this. Okay, so you know you're gonna scrape out some of your thermal paste. Now the instructions with Thermal Grizzly says they want you to roll it into little balls, and then you place the balls on top of you know, whatever component you're trying to cool. I feel it's better. I mean, you can experiment all you want. I feel like it's better to just apply it to the chip, and basically it's about the consistency of peanut butter. But basically, you're going to want to just cover the whole face of the chip, and it's, you know, it's kind of messy, but just spread it out. It's better to have too much than too little. It's non-conductive, so you can't damage anything. You're just going to maybe waste some money, but you know, you might be wasting a bunch of money with Tesla, having them replace your computer for what I hear costs about $2,500 to $3,000. So, you know, it's worth a shot. You're gonna kind of, you know, you kind of want an even layer going on. You might, you know, you might be able to just look up, you know, like videos of people doing like video cards. This is a lot like a video card. Same sort of like layout. You know, you have a processor, you have RAM, you have power management devices. You might be able to find a better video on applying this stuff, but usually though, on a video card for the processor, you're not going to use thermal putty. You're going to use like a thermal grease. But the way Tesla designed this, you're going to need thermal putty because of the distance between, when this is installed, the distance between the processor and the water block is too great. I measured it on the Intel version, and it's about 0.24 millimeter. So much too great for thermal grease. It'll just leak out. So anyways, you get a good amount. See how it's pretty thick there. Good amount on your processor. You kind of want to center it, you know, more towards the center. You're going to put some on your memory and stuff like that. I'm just doing this for demonstration purposes. You're going to put thermal paste on thermal putty on either the board where it was before, or you can put it on the heatsink. The big thing to remember, of course, like I've said before, you can't have too much. You can only just kind of waste money. So you're gonna want, because it's gonna, you know, if you when you look at it, when you take it apart, you're gonna see it's just a mess. There's tons of it, and a robot put that on. So, like, it does not matter as long as you are using non-conductive thermal putty, which the Thermal Grizzly, all their putties are non-conductive that I'm aware of. At least the basic, advanced, and pro are non-conductive. I don't know if they're going to come out with something else or if they have something else. Anyways, so you're going to get a good amount. You're going to spread it around, and basically you're going to do that on your chips, and you're going to put it together. Now, if you're a little, you know, like you don't know if you have enough, you don't have too much, one thing you do is you can do a test fit. So we got it on our processor. We're going to reinstall the board gently and basically just push it down. It'd probably be best to just put the screws in and torque it and all that. Let it sit for a little bit, let everything kind of, you know, settle. But for this demonstration, I'm just going to push on it, and I can tell it's seated completely. We're good, and then we can just pull it off. Now, of course, it's going to take a lot of force. There you go. You can see how it eventually let go. Okay. So you can see we basically got contact all the way around. You can see how it's been smushed out. That was probably about I'd say the right amount for the processor, or the autopilot processor. That's the gist of it. You just want to do that. I would just do, if you're a little hesitant, you know, do a couple practice areas, you know, if you're not sure, like on these MOSFETs, if you're going to have enough. So, you know, just smother it on there, install it, make sure it squishes out, make sure you get full contact, and then you know about, clean it up again. Make sure, to make sure that you're applying enough. Because if you forget to cover, one of these with thermal paste or thermal putty or enough thermal putty, and you put it together, it may run just fine. It won't give you any indication that it is bad until you have a latent failure of, this chip failing, and you lose a power phase, and then that processor dies or goes offline. So you just want to make sure you want to be thorough. You want to put enough on each thing. Look at some videos on audio. I know there's tons of videos on doing video cards with thermal paste or thermal putty. So try and extrapolate that sort of knowledge and apply it to this, and you should be good to go. So apply thermal putty, all that good stuff, and reassembly is basically the opposite. What we did in reverse. The disassembly in reverse. Make sure you labeled all your screws. That's a big thing. Put it all back together. Put it in your car. I would recommend, before you hook up your coolant hoses and start flushing start purging water, your coolant system, just get it electrically hooked up, all your connectors and stuff. Start the car up. Unplug your water pumps, because you don't want it trying to pump fluid out, coolant out. Unplug your water pumps. Start the car up. Hook your 12 volt and your contactors back up, your contactors, and then your 12 volt back up. Let the car boot up. Go back into service mode. Go into your driver assist and make sure everything's good. Make sure the temperatures seem reasonable. Of course, it's going to start to heat up really quick, because there's not going to be any water in this or any circulation. But just make everything kind of looks okay, and then once you confirm that, go ahead, turn it back off. Shut everything down again. Disconnect 12 volt contactors or the battery connector, and then finish the installation. This will hopefully save you a little time if maybe you didn't get a connector right, or maybe like, I don't know, maybe you didn't get your wireless card seated correctly or something like that. And that's basically it. I don't know, I've been rambling for a while. I got like 2 hours of footage of just this. So yeah, if you have any other questions, just ask in the comments. I'll either make a follow-up video or just reply to you there. Hopefully this helps you out and save you from spending $3,000 on a new computer, or junking the car or something like that. So thank you.